What is the length and coordinate units of the altitude from Z to XY in triangle XYZ shown in the standard XY coordinate plane below? There's the diagram. Let's go. Now, this problem is not that hard in that there's not all that much you need to do to figure it out. Like, you don't need to use the distance formula, which is fortunate. But you do have to know a definition pretty well. You have to know what an altitude is, and then there's kind of a clever trick to see here. An altitude of a triangle is the height of the triangle. And so if I'm drawing a right triangle, the altitude is the vertical leg of this triangle, which is kind of obvious because altitude is when we talk about how tall something is or how vertical something is. So the altitude here would be like another word for the height. And so the altitude of this right triangle would be this vertical segment here, right here. And then this would be my base. So here's my base, here's my height. Another word for the height is the altitude. But when we're dealing with a triangle that's not a right triangle, maybe it's not so obvious. When we're dealing with a triangle that isn't a right triangle, let's draw something like, I don't know, how about like this? Now, the altitude of my triangle is not necessarily going to be one of my sides, and it doesn't have to be. But what the altitude does have to be is it has to be perpendicular to the base to which you're drawing it. So if I want to call this leg of my triangle my base, which makes sense because it's at the bottom, then my altitude has to be the vertical height of that triangle measured perpendicular to that base. Again, it has to be perpendicular. So in this case, my altitude would be this segment right here that I could draw in the middle of the triangle so that it hits that base in a perpendicular way. But the altitude has to be perpendicular to the base. That's the key. Okay, well, let's apply that to this problem. Now, you might not know how to do that because you can see that this is our triangle and then our altitude would be this vertical segment right here because our base would be down here. But how do we get that length, right? Well, remember that this is on a coordinate grid. Okay, so I'm going to switch colors here. I'm going to draw this in red. Every point along this line apparently has a y value of 2. So if I think of this on a coordinate grid, there's like a y value of 1 would be right around here. A y value of 2 would be everything along here. A y value of 3 would be everything right around here. A y value of 4 would be everything right around here. And a y value of 5 would be everything right up here. Well, that makes sense because this coordinate has a value of 5 for its y value. So think about what we're asking. We're asking what's this altitude? What's this blue segment's length? And everything at this line has a y value of 2. And then 1, 2, 3 lines away or 3 units away in the vertical direction, we get to this other point. So if I think about this being on the grid, a y value of 2 up to a y value of 5, that blue segment has a length of 3. And I don't have to do any fancy calculations to do it as long as I understand y value of 2, y value of 5. That means those are 3 units apart. That means our altitude is 3 units in length. So our answer here is A, it didn't take any sophisticated calculations to do it. If you got that, great thinking.